If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in permutation combination. So in this lecture, I will see the introduction to permutation combination. What is the basic difference, how it started from fundamental principle of counting, and then some basic formulas. Okay, then let's see this. Okay students, so the topic is permutation combination. We have already discussed a little bit about permutation combinations in binomial theorem introductions. So some basics, we will go in deep here. So if I again start with the basic things that I always start in case of permutation combination, the basic definitions of both these two and what is the difference between these two. So if you see permutation is selection plus arrangement. That means you are doing two work here at a time. So an arrange, that is permutation, and combination means only selection. So that is only one job. That means you can segregate it like this. Your washing machine, suppose your automatic washing machine, your washing and drying both is automatically done, and after drying the net the cloth that comes out, and so both these automatically done. So you have no control over how many. Suppose you want to wash 10 clothes, but you want to dry 7 clothes, not 3 clothes. So you don't have that luxury in that automatic washing machine, because if you give 10 cloth, then ultimately at the end 10 cloth will come after dry after washing 10 and then drying. Both this process will be done in it. So in the intermediate position you cannot control. Suppose you want to after you have given 10 clothes, so you want to wash all 10 clothes, but 7 cloth you want to go for drying, and 3 cloth you want to add some ujala blue color like ujala. So you cannot do it in case of permutation, because the job will be done. Once you give 10, then finally both the things will be automatically done and final output will come. So if you want to break it and then do it, then you have to break the process. You cannot use permutation. Combination means only selections. So in permutation, what is arrangement? So if there is a meaning of arrangement means you are changing the order. That is, suppose A, B, C, so A, B, B, A, these are different arrangements. So it is written in this fashion: an arrangement of definite order. Order is maintaining. That is first A, then B, or B, A. So both these two are different arrangement. This is only one selection, because you are selecting only A and B. Selection is only one, but arrangement is here two, because you are arranging in two different ways. So definite order by taking some or all of the number of things is called permutation. So you can take 2 at a time, you can take 3 at a time, you can take all the numbers. Suppose there are 10 numbers, you take 10 at a time. You take 2 out of that 10 at a time, and then you can arrange them in the sitting arrangement, suppose say. Combination, only selections. That means you are doing only selections, no arrangement. So each selections without any reference to order. So there should not be any reference to order, which one is first, which one is second, that doesn't matter. You just select one to select. So in that case, that can be made by taking some or all number of things. You want to take 3 items out of 10, you can take 10 out of 10. That is known as combination. So all the permutation combinations, they starts from this basic thing, that is fundamental principle of counting. Suppose I tried to give example, as many as example in each article, so that you can relate with why it is happening with real life. Let's an event can occur in m different ways, whereas another event can occur in n different. So these are two different events. Then the one is occurring in m ways, one is occurring in n ways. So you want to do the total number of ways of the simultaneous occurrence. You want to have both the events should occur, then in the definite order, in a particular order. Suppose first you want to this, then you want to this, then the total number of ways is m into n. Now you can think it can be extended for any number. Suppose there are 3 events, so m into n into p it will be. Suppose one example, suppose A to B, A is a place, B is a place, C is another place. So from A to B, to reach from A to B, there are 3 different ways, you can see, and from B to C there are 2 different ways too. So if someone wants to go from A to C, so in how many ways total possibilities? So you want to occur both these events. Via B you want to go to C. So A to B will also occur, B to C will also occur. So both the event will occur simultaneously. The first this one, then this one. So it is in definite order also. So in a definite order, simultaneous occurrence, both is satisfying. So the answer will be 3 into 2. You can see how it is. What are the 3 ways? I have marked this road: small a, small b, small c, small d, small e. So one can use AD, One can use AE, one can use BD, BE, CD, C. So you can see this is the 6 ways. If you want to write it manually also, without maths also, basic logic, first this, then this, then this. So this is one way, this to this is another way, because from here to here it should be a new root. So from here to here it is a root, and from here it is another root. So you can see from basic analysis also you can see it is 6, and from your maths also it is 6. So this is the known as basic counting principle. Now some useful notation before we go to this one, we have already seen in case of binomial theorem. N factorial is anything factorial. If I say there are two notation, these and these. So from that number you try to take product up to 1. That is, if I say 5 factorial, 5 into 4 into 3 into 2 into 1. If I say 3 factorial, 3 into 2 into 1. 0 factorial, 1 factorial, by definition 0 factorial is 1, 1 factorial will be always 1, because you are ending at 1. 2n factorial, you can write it 1, 2n factorial is 1, 2, 3 up to 2n you are going. So what you can say, you can take all the 2's common from the even numbers, 2, 4, 6. So how many is 2 will be there, because there are 2n numbers, so n even, n odd. So all events, from all events you are taking 2 common, so 2 to the power n, because in 2n numbers, n number even numbers are there, n numbers odd numbers are there. From n numbers even you are taking 2 common, so 2 to the power n common. And if you take that common, then from even numbers, then it will be 1. You can see these are the even numbers. So if you take 2 common, so it will be 1, 2, 3, similarly dot 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 up to n. So 1, 2, 3 dot dot n, that becomes n factorial, and 1, 3, 5, this is separate series of odd numbers. So you can write it in this way also. Factorials of negative integers are not defined. So you remember this one. Factorial is defined for only non-negative integers. So let's see formulas. Formulas means different scenario where which type of formula you will use or what concept you will use, because in permutation and combination there will be lots of scenario. So scenario based, these 1, 2, 3 you can think these are the scenarios. First the basic one, number of permutations of n things taking r at a time is NPR. What is NPR? N into n minus 1 into n minus 2 up to n minus r plus 1, which is also written as n factorial. You can introduce now, you can put when n minus r, next term will be n minus r, then n minus r minus 1 up to 1 you can introduce in the numerator, in the denominator also. So that portion becomes your, if you are starting from n, you are going up to 1, so it becomes n factorial. In the denominator starting from n minus 1, because this term you are giving extra in numerator, so in the denominator also you give up to 3 to 1. So this becomes your n minus r factorial. So this is proved. So one thing you have to remember, r should be less than equal to n, because the number of items you are taking, that should be less than number. Out of 10 you cannot take 11 items. So you are taking out of n items, so your r should be less than or equal. You can take full 10 out of 10, and your n should be a natural numbers, and this r should be a whole numbers. Natural number means total number, you cannot have 0 number. So out of 0 how you will take, how many you will take, and what arrangement you will do. So it should be natural number, at least one number should be there, so that you can do something with that number. And how many numbers you are taking, you can take 0 number, you can take 1 number, but there in the box that should be natural number. What you take, that can be whole number, you can take 0 also, that's why it is whole number. So the NPN is one thing also you remember, NPN, what will be NPN if you put it n instead of r, so it n minus n 0 factorial, so NPN is nothing but n factorial. Now how to see this one in real life? Suppose you can think it of sitting arrangement questions. Suppose 3 persons are sitting in a chair, so you want to sit 3 persons in this sitting arrangement. 3 chairs are given, 3 persons is given. So first you start with this, any chair you can start with. So if I start with this chair, how many ways you can fill this chair? You can put 3 persons means 3 different, A, B, C, all will be different, looking different, their looks will be different. So you can put A, B, C, any of these people here. So there are 3 ways to fill this one, like this way you can think of. So from A to B there are 3 ways to fill this event. This is one event, this is one event, this is another event. So there are 3 events. First to fill these chairs, next to fill this chair, next to fill this chair. So you have to do all the 3 events simultaneously and in a particular order, like this question. So I am doing one by one. To fill this one, we have 3 options. Now to fill this chair, you have 2 options, because one person has already said. You don't know which person have said, but one person, someone out of these 3 has already occupied this one. So you don't have 3 persons left with you, you have only 2 persons. So the number of way to fill this one is 2, and number of way to fill this one is 1. So total, you have seen this one, it is m into n into p, m into n into p. So it will be this into this into this. So it is 3 into 2 into 1, which is also known as 3p3 out of 3. 3%, you are taking all 3 and then you are arranging that 3%. So which is 3 factorial, which is 6 also. So using this formula. So from that where this formula is coming n minus 1, you can see 3 minus 1, then 3 minus 2. So you can see every time 1% is reducing. Now the same question you can now think of 4% in 2 chairs. Suppose 2 chairs, so you are taking 2% at a time, then you are arranging. You don't need 4% now. So you need 2% out of 4 to arrange. So it is 4p2. So it is 4 factorial by 4 minus 2 factorial, or this one is the answer. Now you see, if you want to do it manually without that formula, you want to do it from your own mind or known logic. How to fill this chair? There are 4 ways. How to fill this chair? There are 3 ways. So if you complete this total event is 4 into 3, that is 12. So now you can see why it is n minus r plus 1. It is 3 is nothing but actually 4 minus 2 plus 1. That's why it is n minus r plus 1. Because you need 2%, so 4 minus 2, 2, but it will stop 1 before, because you are starting with, you will write 2 numbers. Because you are starting with 4, that's why it will stop at plus 1 is coming. Now next, the second one, it was the basic formula for NPR, same basic formula for NCR. Number of combinations of n different things taken r at a time. Now you are taking r, you are taking 2 out of 4, but you don't want to arrange them. So your job is now only one part, not these 2 parts. So now this was one event, this was one. Both this event was included in the permutation. So from that you want to exclude this event. So if you want to include 2 different events, you are multiplying. So if you want to exclude one event, then you have to divide also. So you will see this one. So the formula is here NCR. Out of n, you are taking r at a time. So it is n factorial by r factorial into n minus r factorial. Or which is also nothing but you are doing NPR. That means you are taking 2 out of 4 and then arranging, that is 4p2. I am taking this example. Suppose I want to select only 2 out of 4. So you are taking 2 at a time and doing the permutation. That means entire thing is done. But you don't need this arrangement. So the arrangements of this, there was the arrangement of 2%. So 2%, how many ways you can arrange? 3% if you want to arrange, it is 3 factorial. 2% you want to arrange, it is always 2 factorial. So if you are arranging r%, that means r factorial. So that's why you are dividing r factorial. Suppose there is no selection, only 2% is there. So how many ways you can select? A, B, B, that is 2 factorial. No selection, 2, 1. So in 2 into 1, 2. If there are 3%, then 3, 2, 1. So 3 factorial. No selection, suppose 3% you are arranging it. So you have taken R, okay. Then you are arranging R also. But I don't need that arrangement in combination. That's why you exclude that one. So exclusion is done by dividing. I don't want to dry that cloth. So that's why that drying portion has been eliminated. How? By dividing this one. So from their permutation, selection plus arrangement, your arrangement is removed. So that's why this is the way to remove. This is the way to include by multiplying. So this is the way to remove by dividing. So again R, this already I have explained why this is so. Suppose you are taking 3% out of 10, then it is 10C3. The formula is 10 factorial, 3 factorial, 7 factorial. There are shortcuts also to calculate 10C3. I have discussed in, I think, in binomial. I will discuss in later stage. So we can write 3 numbers starting from 10, 10, 9, 8, divide by 3, 2, 1. If you do this one, then it is 120. Or you can use this factorial notation also, open it, you will get 120. If you like the video, then press the like button and please give your valuable comments in the comment section.